a battery of internal resistance 4 ohm is connected to the network of resistance as shown here. In the order that maximum power can be delivered to the network, what should be the value of R? Is the question clear to you? When is the power delivered maximum? When small r is equal to capital R. Okay. Oh, hello, in the man. Illu. In the measure. So we want to make small r is equal to capital R, but that capital R means external resistance, बराबर ने? So here how much is the internal resistance? 4 ohm. And what is the external resistance connected? आपको एक combination दे ना R ने वो दो. Yes or no? Sure. Okay. Is there anything that is in series or in parallel? Definitely. Yes. Any simplify and draw it? Give it a try. Hurry up. Simplify and draw कर दो. ऐसे कहीं झंझट नहीं. So, what kind of circuit is this? Is it a Wheatstone bridge? Yes. Okay. Is it balanced or not balanced? Not balanced. Balanced. Yes. See, on the left side the ratio is R upon 2R. Correct or not? On right side the ratio is 2R upon 4R. I hope everybody is seeing that. Yes or no? Okay, so here the ratio is R and 2R divided, and over here it is 2R and 4R. So this is a balanced Wheatstone bridge. So what to do with 6R? Remove it. Alright? So remove 6R. So then how much is the total resistance after you remove this? How much is the total resistance of all this? Right minimum, use your brain maximum. Come on. R to R. 3R. 3 and 6 in parallel. 2. Is that okay or not okay? So final equivalent of all this is 2R. Did you understand? Okay. Now this is connected with a cell, and that cell's internal resistance is 4 ohm. Then answer the question. R should be equal to 2. Correct? Because internal resistance should be same as the external resistance. Okay, let's go to the next question. Third. So what's given here? In these three circuits, all batteries are identical and have negligible internal resistance. All the light bulbs are identical and rank all the bulbs in the order of brightness, that is from brightest to dimmest. So maximum brightness to lowest brightness. Okay. Right? So let's say the bulb has a resistance R. What is same in all the circuits? Is current going to be same or the voltage is going to be the same? Voltage, because the battery is connected. But you have to be careful. Now let's first of all compare A with B and C. Let's compare A with B and C. Suppose the battery is 100 volt. Let's say. Then A bulb gets 100 volt. Agreed? Yes. Then how much voltage does the B bulb get? How much voltage will the bulb B get? Will you get 100? You get 100? No, then how much will it get? How much? 50. Clear or unclear? Why? Because B and C are identical and they are in series. So VB plus VC is going to be 100 and both are identical. So equal. Correct? Equally shared. So VB is equal to VC and that is equal to 50. So which bulb will be brighter? A or B? A. Which will be brighter? A or B? A. Clear? Because power of a bulb can be written as V square by R. R to the same as it. So if it gets more voltage, then it will be brighter. Understood? Okay. Can you similarly try for D and E now? How much is the voltage for D? 100 or 50? 100. Sure?
Yes.
Okay. So what's going to be our final answer? C. A will be same as D. Will be same as E. But that will be greater than B and C. Correct? Good job. Measuring instruments. So let's begin with 24. Theory to yaad chhe ne? Meter bridge. Meter bridge or Wheatstone bridge. In a Wheatstone bridge, three resistors P, Q, R are connected in three arms, and the fourth arm is formed by two resistors S1 and S2 in parallel. We can लगाया ही कहीं खबर ना रही, but we just make an educated guess. How करना? This is P. Let's say this is Q. Let's say this is R, and here is the fourth arm. Can you get this? याद आयु ने आओ है ने? भूल गया? Hopefully you remember. Wheatstone bridge. અને આ fourth arm માં શું છે? Two resistances are there in parallel. S1 and S2. So first of all, what would we have to do? We'll have to find their equivalent. Yes or no? Sure, you get this. Example છે ને બુકમાં આવો. જેમાં S ના parallel માં એક 12 ઓહ્મ કેવું કંઈક લગાડ્યું. Just like that, here two are connected in parallel. Then equivalent શું થશે? Shortcut. Use the shortcut. What will be the equivalent? S1 S2 upon S1 plus S2. એવું લખ નાખવાનું પછી relation કર નાખો for balanced condition. Okay, what is the condition for balance? યાદ તો છે ને? The ratio of resistors are equal. બરાબર. Right minimum everyone. D or A. 2000 ने क्या किया? D. Fine. Okay. Let's go to the next one. Length of a potentiometer wire is 100 cm. The EMF of its standard cell is E. It is employed, means used, to measure the EMF of a battery whose internal resistance is 0.5. Read that carefully. Pehla ek cell kidhu, right? Okay, and then it is used to measure EMF of a battery. Hopefully you remember the circuit, how we measure the EMF for a battery or a cell using potentiometer. So our potentiometer wire, we will always draw the simplistic version of the circuit. If you want to draw snake-like, then you are on your own. Okay, this is the potentiometer wire. Now, what is given? It has a standard cell connected to it. So let's say this is that standard cell. E. Did you understand? What's the length of the wire? 100 cm or 1 meter. It is employed or used to measure the EMF of a battery whose internal resistance is 0.5. ये क्या लगा रहा है? आने कई सर्किट के आप ड्रॉ कर रहे हैं. Primary circuit. Do you remember that? Okay or not okay? Primary circuit. Then where do we connect the other battery which we want to measure? आना parallel मतलब कौन ना parallel? Wire ना parallel माम. Is this the potentiometer circuit? There is a galvanometer and a jockey. ठीक है? यार एवढे पता नहीं कि नदी आपको यार. There is a galvanometer R battery and there is a galvanometer here and there is a sliding contact. Is it fine? Okay. How clearly goes the potentiometer na questions na formula નો કઈ એટલું બધું નથી હોતું. If you understand what is given, you will generally be able to solve it. Okay, done. So यानी कि details से what's the internal resistance? 0.5 ohm and its EMF we don't know. Let's call it epsilon, which is unknown. Okay, make the null point or the balance point 30 centimeter from the positive end. And given positive end. I hope everyone has drawn the diagram already. Okay, हम तो एक लाइन में छोड़ देते हैं. बराबर. So now we want to find out what's that unknown EMF. What will I answer? Epsilon 1 upon epsilon 2 is equal to L1 upon L2. પણ આ તો બેઝ એનો છે. તો બીજું છે. Step the other. Where's the other? So we'll have to improvise. Look at it. How we actually got this was that in a potentiometer V is proportional to L. Do you remember? Yes. Yes or no? Yes. Sure? Yes. So you know count. So what we are having is suppose this point A and this is N and B. So the voltage between A and N corresponds to epsilon. Do you agree? Yes or no? Raise your hand if you understood this. આને શું કહેવાય? Principle of potentiometer V proportional to L. તો આ બે પોઈન્ટ વચ્ચે જે વોલ્ટેજ છે ઈ આનો EMF આવે. Why so? Because this is null point. Basics થી કરાવો. યાદ આવ્યું ને? એનું યાદ આવ્યું. Okay. Is this clear? Phi, epsilon means EMF of this cell is proportional to this length. Got that? Okay. Then, what about total length AB? What gives voltage or what is the potential difference between total length AB? Isn't it E? Yes. Isn't it E? Make sense? Yes. E can connected between A and B. So the voltage of A and B is E. So that's why E corresponds to 1 means 100 centimeter. આ 30 લખો તો 100 લખો. હવે શું કરવાનું? હવે શું ફાઇન્ડ કરવાનું? તો કર નાખો. आज June, I hope you see that. But what's the second cell? This one itself is the second. How came that? Because there is no internal resistance, so it's very easy to do. Even if internal resistance is given, we can do it. Right? It's not a problem. Wonder. Answer is A. Yes or no? Yes. You know something? 30, 100, or use this formula if you want. But our formula के लिए use के ही समझ वाले. It's not the standard typical case. Still we are using this formula because we are considering this cell as 1 and this second cell as 2. Okay, and then slide into 2. Okay, 26. The option came out like this. They were the things. Okay. 26 now. Meter bridge is as shown in figure. How long is the wire AB? How long is the wire AB? 50 centimeter. Okay. Be careful. It's not 1 meter long. It is only 50 centimeter long. There is a change. बराबर ने? See the formula next. Logic use करते. When AD is 30 centimeter, no deflection occurs in the galvanometer. So null point क्या है वो? At what distance? 30 centimeter from A. यहाँ A है यहाँ B. This is the potentiometer wire. Here is D, where we have a null point. Okay. How much is this resistance? 6 ohm. And how much is it? R. And this distance is 30. Okay. So, can you write that equation for meter bridge? कैसे करना था meter bridge का? 6 upon 30 is equal to R upon 20. Okay, 70. 20. So, what's that? 4. Clear or not clear? Understood? Okay. Next question. In the given circuit, अच्छा तुमने अगर meter bridge का question आया जो है, yes. There is only one difficult variation of meter bridge possible. तो खबर है non-uniform wire. એટલે પછી કેવું થાય? Resistance here upon resistance here is equal to resistance on that side upon resistance on that side. Have Wheatstone bridge ની formula ऐसा नो balance Wheatstone bridge कहते हैं. Okay. પછી આ છે ને directly proportional to n નો આવે if it is not uniform. So integration કરીને કેવું calculation કરો. બરાબર, that is a good variation of this type of pattern. આ બાજુ કરો ને ઓલી બાજુ કરો એને મૂકી દો. Okay, 27. In the given circuit, no current is passing through the galvanometer. If the cross-sectional diameter of the wire AB is doubled, then for null point of galvanometer, the value of AC will be. वैसे समझाना. The way it is shown right now in this figure, it is already null point. Did you understand? It is already null. Okay. Now, instead of taking this wire, we take another wire with what? Cross-sectional diameter double. Okay, cross-sectional area how many times? 4 times. Yes or no? Diameter double size, the wire no cross-sectional area 4 times because E is equal to pi r square. Got that? So if you do that, then where will be the new null point? Will it be at 2x, x by 2 or no? What is it?
X by 2.
X by 2. Why is it x by 2?
R is equal to rho L by N and R is proportional to 1 over A.
Okay, R is equal to rho L by A. अच्छा तो શું થશે?
R is inverse.
R is inversely proportional to area. So area तो 4 times क्या है? एरिया 4 टाइम दे के डबल दे. हां 4 टाइम तो क्या है? तो x by 4 आ x by 2 आ. Others? No idea? अरे એટલું બધું અઘરું છે? Sit down. Well tried. Let's see. How does what's the basic equation when we get a null point in a meter bridge? આ લખી છે ને કે નહીં? અને કહેવાય ને કે ન કહેવાય? Pure. Okay. If you would take a wire with double the diameter, એવું કીધું ને question માં. If you take a wire with double the diameter, and થોડું simplify કરીને આમ લખી R પણ S is equal to here. Rho L is the null point there, divided by area. અહીંયા upon rho. અહીંયા total length minus L. Suppose 100 minus L divided by area. Did you understand what I have written here? Suppose A to null point. Let's say A to null point, the length is L centimeter. Then remaining length will be 100 by 100 समझ पड़ी गई resistance of A and N or A up to N is rho L by N. Look at this. Does the null point length in any way depend on the cross sectional area? करेगा ना करे? नहीं करे? Why so? Suppose you double the area, then this side resistance will become if you make area 4 times, then this side resistance will become 1/4. The other side resistance will also become 1/4, and the ratio will remain same as R upon X. So will null point shift? Will null point shift or not shift?
No.
It won't shift. You get that? Because the ratio is the same as that, and the ratio depends only on length. So as long as the wire is uniform, the null point will not shift. Did you understand? And now we got a thing. Make sense?
Yes.
What if you change the battery? Will the null point shift? A battery suppose 2 volt ની છે એના બદલે પછી 2 volt માંથી 4 volt what will happen? Same as that, because ratio of resistance does not depend on battery or anything else. Correct or not? Make sense? So, આ તો બાજુ આમને આમ જ આવવાનું. Whether battery is 2 volt or battery is 4 volt. Clear or not clear?
Yes.
What if battery is made 0 volt? So null point क्या આવે? બધે null point જ આવે. અને માર્ક્સ માં null point આવે. બરાબર ને? ન આવે માર્ક્સ માં null point. Okay. 28 question. Of course you need a battery. Principle is that advantage માં current દેખાડે તો જ ખબર પડે કે null point આવ્યો કે ન આવ્યો. 28. The current in the primary circuit of a potentiometer is 0.2 amp. Specific resistance and cross section area, actually area word regular, cross sectional area of the potentiometer wire are this and this respectively. That's a specific resistance and
Resistivity or unit length.
specific resistance.
Or unit length.
What per unit length? Resistance per unit length is called specific resistance. Unit joule. What's the unit?
Resistivity.
Ohm meter. Ohm meter is the unit of
Resistivity.
resistivity. Yes or no?
Yes.
Sure. Everyone get that?
Yes.
Ohm meter is the unit of resistivity. Clear? Sure. So I be the resistivity. So is resistivity also called specific resistance? Yes. Okay, but only in physics. In chemistry book, specific resistance means resistance per unit length. Barabar, I was how confused. There is nothing that you can do about it. I'm so sorry. Barabar, chemistry માં આવશે આવું? હા, આવશે ને. Resistance chemistry માં આવશે. Okay, and એમાં solutions નો આવશે. આપણે ખાલી conductor એવું આવે. Chemistry માં solutions આવશે. Okay. Well then, nevertheless, so this is rho given to us, this is area given to us, and current is given to us. What do we have to find? Find the current there. Potential gradient. Yes or no? Potential gradient कैसे find करें? V by L. Phi is equal to V by L. That's 28. Okay. Current ने બધું આપ્યું છે તો એની સાથે voltage તો કેવી રીતે આપ્યું? How to get out of this problem? V equal to IR. Very good. So you can write it as I into R. So resistance નથી આપ્યું. Resistance નથી આપ્યું તો R equal to rho L by A. That's what we'll do. Sure. કરો ચલો. ચોંટી જાય મેળવવાની દુનિયા. આ બોર્ડ બરાબર એ રીતે વારા રાખે છે. એક દિવસ બ્લેક ને પૂછાય, એક દિવસ બ્લુ ને પૂછાય. આવા ક્વેશ્ચન પૂછાય તો મજા આવી જાય ને તમને જેને બધી એનો મજા આવી જાય
સર સી સી
આઈ ડોન્ટ નો તમે કરી નાખ્યું છે 0.1 who is finding chapter 3 easier than chapter 1 and 2 okay 29 બધું યાદ છે એમીટર કન્વર્ટિંગ ગેલ્વેનોમીટર ટુ એમીટર કન્વર્ટિંગ ગેલ્વેનોમીટર ટુ વોલ્ટમીટર જો હોય તો એકવાર ફોર્મ્યુલા જોઈ લો concept એ જોઈ લેજો સેન્ટેન્સ એક બે લગાવેલા વાંચી લો ફટાફટ 3 of 1 then we'll solve the last two questions and then we'll go on to the next chapter याद આવ્યું એનાથી યાદ આવતું વાંચીને to decrease resistance of galvanometer we connect a small resistance in parallel એને શું કહેવાય shunt okay and then some current will pass through galvanometer and rest of the current will pass through the shunt યાદ આવી ગયું ને બરાબર okay ચલો so keep the diagram in your mind or draw it in the notebook where you are solving this question 29 a galvanometer having a coil of resistance 100 ohm આની value છે G ની value gives a full scale deflection means touches on the maximum but એનાથી વધુ no measure થાય how much for a current of 1 milliampere આની value આપી Ig right current through galvanometer can be maximum 1 milliampere the value of resistance means shunt actually which can convert this galvanometer into an ammeter giving a full scale deflection for a current of 10 ampere what does that mean we have to convert this galvanometer into ammeter and the maximum current we want to measure is 10 ampere and any value is I so I's value given G's value is given and we have to find shunt value of air ફોર્મ્યુલા આવડે તો ફોર્મ્યુલા યુઝ કરો ન આવડે તો ઓલા બે પેરેલલ માં છે ડાયરેક્ટલી થઈ જાય ને વોલ્ટેજ ઇઝ ઇક્વલ કેટલો કરંટ જાય એમાંથી કરી નાખો તો થઈ જાય hurry up hurry up come on પછી એનો પછી નહીં કરવાનો છે પૂરો ફિનિશ કેલ્ક્યુલેશન કરવાનું છે એ તો તમારા ઉપર છોડી દઉં છું બરાબર ને યુનિટ જોઈ યુનિટ 1 શું છે 1 મિલી એમ્પિયર છે ને 10 એમ્પિયર મિલી એમ્પિયર માં તો 1 કેટલે You can put Ig as 0.001 yes or no make it easy to calculate S equals G into Ig upon I minus I એવું થાય ને G into Ig upon I minus I so G is 100 Ig is 10 raised to minus 3 upon 10 minus 0.001 fine so what's your answer D આવે છે કેનો આવતો do it without calculator નહીં તો કે મીનિંગ નથી આ શું થાય 0.1 upon શું થાય 9.999 yes or no okay or not okay આની લોટી ભાઈ એનો ફાવે આવું multiply this with 1000 એટલે આ 100 upon 9999 કેવું થઈ ગયું ને approximately કરો એટલે કઈ વાત નથી. This is same as 10000. yes or no? વધી ગયું ને. ચલો 30th last question. This question has two statements. આપણે ખબર છે. Statement 1, higher the range, greater is the resistance of ambient. એમાં બહુ ન ખબર પડી હોય તો સ્ટેટમેન્ટ 2 વાંચી લો. To increase the range of ammeter, additional shunt needs to be used. Range કેતે વધે છે? When we connect shunt, range increases. Yes or no? In fact, એની પરનો ક્વેશ્ચન આપણે કર્યો હોય. ઓકે ઓર નોટ ઓકે? તો હવે શું થશે? Is that true statement or false statement? Second is definitely true. હવે first નું વિચાર. Higher the range, greater is resistance. So if you connect shunt in parallel, resistance ઓછું થઈ જાય વધી જાય? ઓછું થઈ જાય ને. If you connect shunt in parallel, whenever you connect something in parallel, resistance will always decrease. So by increasing the range, we are actually decreasing the resistance. Yes or no? So is statement 1 true? False. Higher the range, lesser will be the resistance. Clear? So it will be false. Fine. Okay, that's it.